Okay, so in this lesson group, we are going to be talking about acid and basis equilibrium. Now, let's go ahead and get into the introduction of acids first. So, what are acids? Acids, they are covalent compounds that has a hydrogen ion. And these will usually be connected to either polyatomic ion or a non-metal anion. And in case if you guys forgot what a polyatomic ion is, it is pretty much a group of atoms that acts together as one charged unit. So what are some examples of these? These include nitrate, sulfate, carbonate, hydroxide, and ammonium. Now something to note of is these are all negative, and ammonium is the only one that has a positive charge. This is usually going to be the common one that you guys might encounter. Okay, so now that we have polyatomic ions out of the way, let's go and talk about non-metal anions, in case if you guys forgot. If you guys remember, you guys can go ahead and just fast forward through this part. Okay, what a non-metal anion is, it's going to be one single non-metal atom that has gained an electron. This means we will have a negative charge. Also, they're going to be ending with I. So what are some examples? Okay, there's actually a small correction that we have to make. This actually isn't gained an electron. I made a small mistake. It should have been a single non-metal atom that gained electrons with an S right here. Okay, so now that we got that out of the way, let's go and talk about some of the examples. We have chloride with the ID at the end, and it's a negatively charged atom. It gained one electron. We have oxide, sulfide, and nitride. These are some common examples that you guys might see. Okay, so now we have gotten a non-metal anion check. Now that we got a refresher of what these two are, let's go ahead and go back into the topic of talking about acids. Okay, let's go and talk about how you guys can go ahead and identify acids. Number one, acids, usually they're going to start with a hydrogen ion in the start of the name. This is going to be H. So hydrogen ions will usually be at the beginning of the covalent compound. However, there's going to be two cases where you won't see this happen. Now, these are going to be for acetic acid and positive amines. Okay, in case if you forgot what amines are pretty much nitrogens bonded to hydrogen. So whenever we see NH on its own, that will fall into this category. So commonly, you guys might see ammonia, which is NH3. Amines are also covalent compounds that contain carbon, nitrogen, and hydrogen. Okay, now that we have these two categories, category 1, category 2, of where positive amines can fall into. Now that we got all of this out of the way, let's go and talk about some common acids you guys might see. If you guys can get this memorized, you guys can go ahead and work through problems really quick. Okay, the board is a little bit messy right now, so what we're going to do is we're going to go ahead and erase it. Make sure you guys got everything noted down before we erase it. Okay, so over here what we have is hydrocyanic acid, hydrosulfuric acid, hydrochloric acid, phosphoric acid, acetic acid, ammonium, and over here last but not least we have methyl ammonium ion. As we can go ahead and see, all of these non-metal anions for the first four all has a hydrogen in the beginning. If you guys forgot, remember these two rules, rule number 1 and rule number 2. These two are how you're going to be able to do this. Basically, very simply, from a concept standpoint, be able to identify acids. We can go and see all of these 4, 1, 2, 3, 4, all starts with hydrogen in the beginning. And it also ends with a non-metal ion. Over here, phosphoric acid, we have a polyatomic ion at the end, not a non-metal anion. Okay, so now that we got all of this out of the way, let's go and talk about the last three, because these are a little bit special cases. Remember when we said there's two exceptions to this rule, and they are acetic acid, which is this one, as well as positive amines, which we have right over here. So there's two ways to actually write acetic acid. This is the first way, and the second way to write it is HC2H3O2. Now, in this format, we can go and see there is going to be a hydrogen at the beginning. But if it's written in the other format, we can go and see the hydrogens at the end. So it doesn't really start in the beginning, like what we have rule number 1 is. Okay, now the last two. Now that we got this one also out, we probably should have used blue, but now that we got this one out of the way as well, let's go and talk about the positive amines. We can go and see number 1, the first one, which is this one. It's a covalent compound that includes nitrogen and hydrogen right over here. So this will fall in the first category. So this will also be an acid. Number 2, we can go and see this falls in the second category that we have for positive amines, which is it contains carbon, nitrogen, and hydrogen, which we have right over here, which will also make this one fall under the acid category. Okay, now this is a little bit of a mess, but if we go ahead and erase the entire mess, we just come down with a few common acids that it might help for you guys to go ahead and remember, especially for quizzes and exams. You guys can go ahead and run through problems really quick as soon as you guys can identify these. And it's also good to know acetic acid written in both formats. Okay, now something to note before we move on to the next part is these two amines are positive. Now usually whenever you see a positive amine, you can go and put it into this category of being an acid. But when we have this normal amines and negatively charged amines, that makes things a little bit more complicated, which we'll go ahead and talk about later on. But there's going to be an introduction of how you guys can go ahead and identify acids and what are acids, just by looking at their chemical formula.